In this video, I introduce a restricted Boltzmann machine for movie recommendation. Restricted Boltzmann machine is an undirected two-layer graph that consists of one hidden layer and one visible layer, which can be used to predict the user's rating for a movie. The binary hidden units are used to capture dependencies of movies for different users. Here, we consider M movies and N users. The rating values are integers from 1 to k. For example, given observed ratings V, the model can be used to predict the rating of a query movie Q. Run the restricted Boltzmann machine, we get the corresponding parameters that are used to predict the rating of a movie Q, given observed ratings V. A softmax function is used to model each visible unit, and the conditional Bernoulli distribution is used to model each binary hidden unit here. Where Wij is the model parameters of a movie key, the marginal distribution over the visible ratings V is defined as a margin of a softmax function over H, where energy function E is defined as edge energy, and the energy is related to bases BIK and BJ. To update the model parameters Wij, we need to compute gradient of the log likelihood as the difference of two expectations over data distribution and the model distribution. Markov chain Monte Carlo and Gibbs sampling can be used to compute the expectation over the model distribution. However, they are time-consuming. Here we use the contrastive divergence to approximate the expectation over model distribution, since it only requires running the model one step. For example, at t equals 0, update H from initial value V to calculate the expectation over the data distribution. And then at t equals 1, update V from H, and then calculate the expectation over the model distribution. The constructive divergence is a one-step Gibbs sampling that is used to generate a roughly searching direction. Given the observed ratings V from one user, the model can predict the user's rating for a new query movie Q. Using definition of marginal distribution V, we have this conditional probability of movie Q that is expressed as a margin of exponential over H. Using the formulation here, this probability of H is equal to product of independent probability of HG. We got this formulation. HG can be 0 or 1. If HG is 0, we have this one term because this is 0. If HG is 1, we have this exponential term. We run the model, use the observed ratings V as our input to generate this model parameters. And we run the model again using the query movie as our input to get this model parameters. Put together, the model predicts the rating of the new query movie Q. Once obtaining and normalize the scores, we can select the rating with the maximum score as the prediction. For more details, please check with these references. Thank you. Bye.